Here's the solutions to the algebra expanding test. So let's work the problems. For question A, we've got 3 lots of x, take away 1 lot of x, that equals 2 lots of x. For this one here, we've got some unlike terms here, so 4 plus 2x can't be added together, so we're going to pick the x terms out and add them. That's 2x plus 5x, that's 7x, and 4 plus 3 is 7. So 7x plus 7. Right, over here we've got 7x squared, doesn't have any like terms. Negative 2x, take away another 7x is negative 9x. So let's go, this equals 7x squared, take away 9x, and that's unlike with anything, so 7x squared y. Alright, this one here we've got 3 lots of y, which is 3y times negative 4. We've got a positive times a negative here, which is a negative 3 times 4 is 12y. Alright, over here we've got 2x multiplied by 3, which is 6x plus 4x, and the answer there is 10x. Alright, this one was a little bit tricky, girls, and a lot of you got this one wrong. So a lot of you went 4a take away a is 3a first of all, but you needed to make sure you adhere to the order of operations. So what we've got to do is actually do the multiply first. So if you want to imagine it, that's like in a bracket. So we've got a negative times a negative, which is a positive. A times 3 is 3a. So we've got 4a plus 3a plus 5. That's 7a plus 5. Right, on to the expansions. Over here we're using the distributive law, and we're going to do 3 lots of p, 3 lots of 2. So that's 3p plus 6. Alright, here we've got this expansion to do here, which is just x plus 5 plus 4 x plus 5, which is x squared plus 5x plus 4x plus 20, which is x squared plus 9x plus 20. Alright, over here we're going to do it a bit of a different way. We'll use this method of, if you've heard of it, FOIL, front, out, in, last. Okay, we're going to multiply the front terms, which is 14, the outer terms, which is negative 21x, the inner terms, which is negative 10x, and the last terms, which is 15x squared, which is 14. We've got negative 21 take 10 is negative 31x plus 15x squared. Alright, here we've got a perfect square expansion. You can do this by rule, or you can do it the old school way, which is write it out and do the full expansion. So that's 4x squared plus 8x plus 8x plus 16, which is 4x squared plus 16x plus 16. Alright, we've got difference of perfect squares situation here. So what will happen is the middle terms will cancel each other out, but if you didn't know that, just do the full expansion. M squared plus 3m, take 3m, take 9. These cancel out, leaving us with m squared take 9. Same situation over here. We've got 100x squared, take away 90xy, plus 90xy, take away 81y squared, which is 100x squared, take away 81y squared. Alright, so the multiple choice, lots of people got this one wrong, the coefficient of the x term. Okay, that's the coefficient there, negative 3, not positive 3. When expanded, which of the following would be difference of perfect squares? So we're looking for same first term, same second term, and a plus and a minus. So that rules this one out, rules that one out. Same first term, same second term, plus minus, it's C. When simplified, alright, so what we need to do is expand this, and it's a pretty tough expansion. So we've got negative 15m plus 10mn, take 10mn plus n. So what will happen is these will cancel each other out, and we've got n take away 15m, a. This one here, a couple of my students said that there was a mistake in this one here. The term 3y squared a is like with which one of the following? It's actually this one here, okay? Because 7ay could be written as 7ay squared, and that is the same as 7y squared a, and you can quickly see that that's like. Alright, if the formula for area of a triangle is this, what's the expression? So what we've got here is the base, so the base is 3, the height is this one here, the perpendicular height, so that's multiplied by 4y, and we're dividing the result by 2. So that's 12xy divided by 2, which is 6xy. Got one there. A number has 5 added to it, and the result is squared. So x has 5 added to it first, and the result is squared. That one. If I expand this one out, again it's using the distributive law, 3x plus 6, or negative 3x plus 6 rather. Here it is. When expanded, this is equal to x squared plus 2x, take 5x, take 10, which is x squared, take 3x, take 10. There it is. Alright, this one here was a tough one. We got 10x, subtract x, subtract 2. Okay, when I expand this one out, that's 10x, take away one lot of x, take away 2. Right? So a lot of students will take the x and then add 2 to the result, but you want to be careful of that. Okay, so that's 9x take 2, which means that B is the answer. Heaps of students got this one wrong as well. We're looking for the area that best, the expression that best represents the area. Well, this is an area model, so let's do x times 2x, which is 2x squared, x times 3, which is 3x, 1 times 2x, which is 2x, and 1 times 3, which is 3. And now we're going to add the composite rectangle together. It's 2x squared plus 5x plus 3, which was C. Alright, we got the card to wish Ms. Duong well. So the length of the card is 2x, width is that, and we want to write the area. So you just need to remember the area is length by width, which is 5 plus x all multiplied by 2x, which is the same as 2x multiplied by 5 plus x, and we have to write it in expanded form, so that's going to be 10x plus x squared, 2x squared. Okay, in order to post the card to Ms. Duong's home, Ms. Hayes purchases a rectangular postage stamp with an area of that. If the width is unknown and the length is 2x, what would be the width? So let's draw it up. So we get a length 2x. We need to work out what this is so that the area is 4x squared plus 12x. Okay, so we're doing 2x multiplied by something will give us 4x squared plus 12x. So there's a little bit of trial and error here, girls, because if you know factorising, this is fairly easy, but you guys don't know that yet, so you had to trial and error this one. So if that's 2x multiplied by 2x is 4x squared, so that must be the first term. And then I think, what would 2x be multiplied to make 12x? Well, that's 6. So therefore, this unknown measurement must be 2x plus 6. Okay, we've got this new computer monitor, which is made up of a rectangular screen surrounded by hard plastic. So we want an expression for the length and width of the screen. So this is the screen here. Okay, so this length here is x. We're going to do x, take away this here, which is 2, and this here, which is 2. X take away 4. Okay, and that will be the length. Then the width, same deal, it's down here. So we're going to do x, and we're going to take 3 and take 3, so it's going to be x take 6. So we want to write an expression for the area of the screen using expanded form. So the area will be x take 4, x take 6, which is x squared take 4x, take 6x plus 24, x squared take 10x plus 24. Alright, and the last one, so this question was pretty tough. So what we've got is Ms. Duong spending some time while she's on leave at her family's property. Their land is 30 metres wide and extends down to the water's edge. At low tide, the length of the land is 55 metres, as shown. Okay, so there's the length and there's the width of her property. Alright, using the pronumeral x, write an expression for the length of the land at any time of day. So the tide is going to come in, okay, and the tide and the distance the tide comes in is unknown. Okay, so the length of the land in this case would be 55 subtract whatever distance the tide has come in, or 55 take away x. Okay, so show that the expression for area of the land at any time of day is that. So what we're going to do is get the area, which is 30. So area is 30 multiplied by 55 take x, and when you run the distributive law, 30 multiplied by 55 is 1650, take away 30x, and that's enough to show that. What's the area of the land at low tide? Well, that one's easy. 30 by 55 equals 1650. Okay, a lot of people got this one wrong. The difference between the area at low tide and any time of day. So low tide is 1650, subtract any time of day, which is 1650, take 30x. Now 1650 take away 1650. Now think about what this says. We're subtracting negative 30x, so in fact that has to be add. They cancel out, leaves us with 30x. So we only accepted positive 30x there. Alright, so we're going to factorise each of these. This is the bonus section, so if it's not relevant to you, tune out now. So for this one, we're going to pull out the highest common factor, which is 8a plus 3b. So 3 8s are 24. Alright, here we're going to pull out this common factor, which is 6 take away q, leaving us with 12p take 5. This one here is a DOP scenario, that's x squared take away 7 squared. And now that we've got it in difference of perfect squares form, it's easy to just send it over to factorised form. This is also DOPS, so we're going to rewrite this as x take 3 take 6 squared. And now that it's like this, we're going to say this is x take 3 take 6, x take 3 plus 6, which is x take 9, x plus 3. Alright, we're going to group this one here, okay, and what you'll find is that the grouping as it was wouldn't be possible with this. So what we're going to do is just pair the terms up. So I'm going to do 16x plus 4 plus 12xy plus 3y. I'm just reordering the terms. Alright, I'm going to split it and factorise this side, which is 4x plus 1 plus 3y, that's 4x plus 1, which then factorises to 4x plus 1, 4 plus 3y. Alright, down here, you can use the cross method or whatever method you wanted to for this one here, but negative 8 is the target number. It's going to be 4 2's, one of them has to be negative, and it's going to be this one here. So it's x plus 4, x take 2. Right, same deal over here, negative 27 is our number, 9 3's are the factor pair, one of them has to be negative, and it's going to be this one, x take 9, x plus 3. Right, this one here, you try the basic method and it's not going to work, means you have to go to plan B, and so what you need to do to factorise this one is to complete the square. Alright, so to complete the square, what we do is we write x squared plus 10x, and then we take this coefficient here, halve it, square it, add it, subtract it. So I'm going to halve it, which is 5, square it, and add it, which is 5 squared. Take away it, which is 25 plus 3. That's x plus 5 all squared. To factorise that portion of it, take away 22. Alright, now we need to factorise this, so we're going to use the difference of perfect squares. We're going to square root that and square it to make both of these a perfect square, which gives us x plus 5 take root 22, x plus 5 plus root 22. Alright, so this one here is what we call a non-monic trinomial, because the coefficient is a value other than 1. You would have tried to take out 6 as a common factor and not succeeded, so then you need to use the grouping method or the cross method to try and factorise this. Alright, so I'm going to use the grouping method. That's my preferred method. So 6 15s are 60, that's negative 90, and our factor pair that makes negative 13. Oof. This is a little tricky. Let me think. 45, 30. Alright, I'm going to pause this while I come up with a factor pair. Alright, so the factor pair is 18 times 5, and the 18 will be negative because one of them has to be negative. So we're going to write that equals 6x squared, take 18x plus 5x, take 15. And we're going to group that 2 and 2, which is 6x, x take 3, plus 5, x take 3, x take 3, 6, x plus 5. Alright, so there's the solutions.